Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah rabbil alamin, wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Amma ba'd. Hi everyone, I hope all of you are in best health condition. So inshallah today we will continue with our discussion. So for this lecture, I would like to discuss regarding our tutorial for our tutorial 6, which we already finished before for this chapter, and I already provide you with 11 questions. So we will try to discuss all of these questions for this session. So I hope that everyone and all of you can pay attention to this tutorial, and we will try to understand better for the topic with the tutorial given. First, let us start with the first question. Explain homogeneous mixture or solution. So, to answer this question, we need to explain what is the homogeneous mixture. So here's the keyword explain. When we talk about explain, you need to detail up in your explanation. So the homogeneous mixture is mixture in which the composition is uniform throughout the mixture. So here the keyword, the composition of is uniform. So we can put an example here. For example, is the salt water is homogeneous because the dissolved salt is evenly distributed throughout the entire salt water sample. It's easy to confuse a homogeneous mixture with the pure substance because they are both uniform. The differences is that the composition of the substance is always the same. The amount of salt in the water can vary from one sample to another. So here is the additional information for you. The characteristic of mixture. Here, the characteristic of mixture is that they can be separated into their components, since each part of the mixture has not react with another part of the mixture. So, for example, such as if we have what H2O molecule here. So here is the mixture. So why is homogeneous mixture? When we have two or more components in our system. For example, here we have NaCl, NaCl. So here, when we have a component, so here is the characteristic, which is that where we can spray it into the components. So for example, here we have solute and solvent, and then we have solution. So this is where we call it is a homogeneous mixture. Okay, next we go to the next question. Suppose 0.8 gram of sodium chloride is dissolved in water to produce 500 cm³ of solution. Given the density of water 1000 kg per meter cube, the atomic mass unit for sodium is 23 AMU. AMU stands for atomic mass unit. Cl is chlorine. Given the molecular mass is 36.0 AMU. So the question asks us about the molar concentration, and then molarity, and then mole fraction of each component solution. So here, all of the solution, we need to know the formula of each. So So we need to know the formula for each first. Let's see with the first question, the molar concentration. What is molar concentration? When we talk about molar concentration, this is concentration equal to N over V. N stands for mole, V stands for volume, and from N we have another formula where it is mole equal to mass of a component divided by its molar mass. So to answer this question, first we know we need to have our formula. And then first the molar concentration. So we have C N over V. Here it should be C concentration per volume. So here we need to know our volume here. So mole is small, volume should be in meter cube. So we can convert this unit, become 0.5 meter cube. And then we know that our mole equal to mass over molar mass. So first thing first, from the information we can find the mole of sodium chloride, where we have 2.8 gram. We put it here, and then we need to find its molar mass. So we know that molar mass is molar mass for NaCl. The question already give us the mass of sodium and also chlorine. So we can insert the formula. So and then we can get our mole for sodium chloride is 0.014 mole. And from there we can find the molarity. Here is concentration. So concentration is mole per volume. So we already have our mole, and here we have our volume. We take it from here. So here the important thing is we need to know how to convert the volume. Now we have cm cube, so we need to know how to convert cm cube to meter cube. So convert it, so we have to get 0.5, and then the molarity for this concentration is 0.028 molar, or we can say mole per just depend on you. And then we should ask us about the molarity. So we know the formality. So the formality is molarity equal to mole of solute divided by mass of solvent. So solute here, the solute here is our sodium chloride. Here is solute, and the solvent is water. So besides, and then this mass of solvent must be in kilogram. we can convert our volume here to mass. So we already know this formula, density equal to mass over volume. So by rearrange this formula, we can get mass equal to density times width over volume. So you can rearrange this one, and again we need to know how to convert this to meter cube, and then we get 0.005. so we do it, and then we can get the mass of solvent is 0.5 kilogram, and then we put it in the formula. So we find our molarity. It should be molarity, and then we get 0.028 molal. So or we can write it as mole per kilogram. And then the third question asks us about the mole fraction of each component in the solution. So in our system, we have two components, which are water as a solvent and also NaCl. So the formula for mole fraction is the mole fraction of species S equal to this mole fraction, the mole, the system, and the total mole of what is in our system. So we know that for N total, or the total mole, equal to mole of sodium chloride plus mole of H2O or water. So for sodium chloride, we already calculated from our previous question, which is this one. So no need to click back. So but we need to determine the mole of water. So we know that to find the mole of water, again we use the formula of M mole equal to mass divide by its molar mass. And then we know that we already get the mass before here, the mass. So we can convert it to a gram, 0.5 kilogram. We convert it to become 500 gram, and then our molar mass of water is 18, where hydrogen have the mass of hydrogen is 1. And the mass of oxygen is 16. In water, we have 2 hydrogen and 1 water. So we put all the value in our formula, and then we find 27.7 mole. And later on, to find the mole fraction of each component, so here is the formula. We use this formula, and then here is the mole fraction for NaCl. The mole for NaCl divided by its total mole in system. So we have our mole for NaCl is 0.014, while for the water is 7.7. Then we get this one. Here is our mole fraction of NaCl. With the same formula, we just replace the value. And then now we are using the same formula, and now we want to find the mole fraction of water. So again, we just use this is the mole of water. Then we put all the value in the formula, and then we get 0.99. And there is another formula where we already find this one. So what you can do is you just 1 minus if minus is